Welcome. Let's begin with formatting DateTime object. These are the symbols used for formatting those objects. So %d for the day of month from 01 to 31, %a for day of week short as per the local for English or ENUS, Sunday SUN, and %A for full local like Sunday. %m month of the year from 01 to 12. %b for in short the month name like Jan Feb, that will also be print as per the local. %B for full name of the month. Small %y year in 2 digit, capital Y for full year, capital H for 24 hours time format, capital I for 12 hours time format, %J for the day of the year as decimal from 01 to 365, capital U for the week number where the Sunday is the first day of the week, and capital W for a week number based on Monday as a first day of week. So %W for the weekday as decimal, 0 for Sunday, %P for AM PM sign in 12 hours time format, capital S for seconds, capital M for minutes of hour from 01 to 60, capital Z for time zone. So let's use strftime method to format date object first. It returns the string representing the given date and time object in given format. So let's see the formatted output for the given format. So this is by default string returned by the date object. So here %d is a day of month 01 to 31, %b for the month name short, and capital Y for the full year. So capital B will be fully printed the month name, and capital A for the day of week in full name. Next is formatting time object. So capital H will be 24-hour time format, capital I for 12-hour base time format, and %V for AM PM sign. All the other space and character will be printed as it is as given in the format. Only the symbols will be replaced by the given value in the respective table. Next is formatting date time object. So it is a combination of date and time formatting. As you can see here, we execute it. In here we have first provided the full month name, then day of month, then fully year. After that, this is 12-hour format, minutes, seconds, and AM PM. Capital A is a day of week in full. Okay. Next is comparison. So we can compare date object with date object, time object with time object, and date time object with date time object. These are the comparison operator: less than or equal to, greater than or equal to, equals to, and not equals to. Let's perform on date object. So as you can see, D1 is less than D2, so it will return true for less than or equal to, less than, and D1 and D2 are not equal. Same for the time object. As you can see, T1 is greater than T2 and T1 is not equal to T2. And for date and time object, as you can see, D2 is greater than, so D1 is less than D2 and d1 is not equal to d2. Now we can compare the date with date, date time with date time, but we cannot add them together or subtract it. So we need special object for that, which is a time delta, which represents a duration or the difference between two date time or date time object that we can add to those objects to gain a new object with required date time or date time. So this is the constructor for constructing time delta object. So time delta is a class in DateTime module. So it takes days, weeks, hours, minutes, seconds, microsecond and millisecond as a parameter. But out of those all parameters, these three parameters are the parameters in which the actual data will be stored. So for millisecond, 1 millisecond is converted into the 1000 microsecond. For minute, it will be converted into the 60 second. For hours, 1 hour is converted in 3600 seconds, and for week, it will be converted into the 7 days. So let's construct the time delta object using all of these arguments, and let's check how it is represented. So as you can see here, we are not seeing any week into final object when it is printed, but we can see the hours, minutes, milli and microsecond. But if we use REPR method to print it, it internally holds only three parameters: days, seconds and microsecond. So the given object or given parameters are converted into the only three parameters internally. So while printing that, seconds are converted into the hours, minutes and second by dividing with the respective values. So if you want to convert seconds into hour, we need to divide it with the 3600 seconds. So these are the attributes we have explained. These are the three attributes in which all values are converted. Minimum is the most negative value that time delta can hold, and maximum is the most positive value that time delta can hold. And resolution is the smallest possible difference between two different time delta object, which is 1 microsecond. So let's access the parameters of time delta class. As you can see, date, seconds, because we have not provided milli or microsecond, it will be 0. Minimum time delta is this, and maximum is this, and resolution is this. So given seconds, we want to access hours from the time delta object. We can convert the given seconds by dividing by 3600. Function of time delta, total seconds, which will return the total duration represented in seconds. So on this time delta object, if we execute total second, it will convert whole duration into the seconds. Now operations on time delta object. Now time delta object can be added with the time delta object, subtracted, multiplied with, multiplication and division can be applied with integer or float value, modulus operator with time delta object, div mod with time delta object, positive value of it, negative value of it, and absolute value of the time delta object is allowed. So if we execute whole operators, as you can see the result. So time delta 1 and 2 are added, subtracted, multiplied with 2.5, division by 1.5, modulus. Div mod will return two values, as we can see here. First is a quotient and second is remainder. Next is a positive value, it is already positive, so no need. Negative value, which will convert into this. So by minus 18 days plus 13.30 hours, which will be equal to 17 hours. Okay, an absolute value of this. Now the main purpose of the time delta object is to add, subtract from the date or date time objects. So first we will perform operation with date. So we have a date object and we want to add 2 days to the given date. So 22, if we add time delta equal to 2 days, if you print it, as you can see, it will return new object D2, or after 2 days date is represented as 24. Same as that, if time delta is 5 days and if we subtract it, it will return date before 5 days. And if we apply any operation on the given time delta object, which will multiply 2 days into 2, which will be 4 days. So 4 days should be subtracted as expected. 22 from 22, it is returning 18. Now this is operation with date time object. As you can see here, 1 day and 2.5 hours is subtracted from the given date time object. Now time delta object also supports all the given comparison operator as we saw earlier. So less than or equal to, greater than or equal to, all are supported here. So if we execute it, we can see time delta 1 is greater than time delta 2. Time delta 1 is not equal to time delta 2. Next is time zone. So as we saw earlier, in constructor of a time class or date time, we can provide tzinfo as a parameter. So it takes an object of a subclass of a tzinfo class. So it's an abstract base class for time zone classes, and any instance of a subclass of tzinfo is passed in the constructor of a time and date time object. So these are some of the terminologies which will be used. Epoch is second since the midnight of January 1, 1970, which is used in a Unix system. UTC is a coordinated universal time, formerly Greenwich Mean Time or GMT, and DST is a daylight saving times. So let's begin with time zone class. So time zone is a subclass of a tzinfo class. We can use it as a parameter where tzinfo can be given. So this is the constructor of a time zone class. First is an offset. Offset is given as a time delta class object which represent the duration of a difference with the UTC time. An optional argument is a name, which is a name of a given time zone. So first we will construct the time delta and then we will construct the time zone object. So as you can see, time delta object, we are providing the duration of the difference between UTC time and the given time zone time. So Australian Central Daylight Time is plus 10 hours 30 minutes. So we have represented using that time delta and provided as a constructor argument. So let's print it. As you can see, if you print the time zone object, it will only print the time zone name, but if you print REPR, it will print the time zone object in constructor format. Now these are the attributes of time zone object. Min and max is the minimum and maximum value for the time zone, and UTC will return UTC time zone, which means time delta time zone constructed with time delta as 0. Let's execute it. As you can see, this is the minimum value and maximum value that time zone can hold, and if we access UTC, it will return time zone object where time delta is set to 0. Now if we have a local time and if we want to convert it into the UTC time, or we want a UTC time, then we can provide the time zone into the argument of a now method of date time object. So now we'll return the local time, and this will, if we give the time zone into the now method, it will return the time zone time This is the local time of a machine, which is in IST plus 530, and if we converted the same time into UTC, it will be subtracting 530 hours from the given time. Here it is a UTC. Now converting to the local time zone. For that, astimezone method is used. In the DT2, date and time is as per the UTC time, and we want to convert it into the local time zone, which is IST on this machine. So we will use astimezone method. It is converted into the current local machine time zone, which is IST plus 530. Next is the functions of time zone. First one is a UTC offset, which returns the fixed value of time delta specified in the constructor of a time zone. So if we have specified here 10 hours 30 minutes and 7 hours, it will return the same thing. So let's first create object and let's execute UTC offset. So as we can see here, it is the same offset we have provided in the time delta object. Next is a tzname. So it will return the time zone name of a time delta object. So if we execute this, as we can see, it will return the same string passed as a second argument of a time delta constructor. DST will always return none. So if we execute it, it will always return none. And last method is fromutc. It will return date and time plus offset, and date and time object, date time object must have tzin set. Time zone must be given to it. So these are the date currently represented. Okay, and we want to convert it into the date plus offset. So if we execute it, as you can see, offset are added, and in here it is subtracted. Next is a time module. So earlier we saw the time class of a DateTime module, which returns the time object. Now this time module provides time related function which are useful with DateTime operation. So in this tutorial we will only consider the function which are related to the DateTime object. So let's begin with the related function. First one is a time. Time.time will return the current time in seconds since epoch. It will return the seconds since the midnight of 1st January 1970. So if we import time and time.time, it will return timestamp, which is current timestamp. Time ns will return the same epoch time in nanosecond. Perf counter is a clock with the highest precision that can be achieved to measure the short duration. So suppose we want to measure the execution time of a Python statement, that we can calculate accurately using this perf counter method. So it will return instance of a particular time when it is executed. So we'll take a start time, a time at the start of the execution of print statement, and after executing statement we will take again time, and we will subtract end minus start to infer the execution time. So if you execute it, this is the execution time of a print statement on this local machine. And perf counter ns same as the perf counter, performance counter, but it will return time in nanosecond. So as we saw earlier in example, it is returning 0.002 second. Now this will return nanosecond to execute the difference between counter. So it will return time unit in the nanosecond. So we will take the difference between two time, it will be in nanosecond. Monotonic, it will return monotonic clock that does not go backward when executed repeatedly. As we know, the local time is representing using the quartz, and they are adjusted with the internet time periodically. So they may go backward in millisecond or microsecond. But if we are relying on the system which always returns the increasing numbers, some protocols are required such time which always increases. So in that case we can use this method. So if we execute this method in short duration time, it will always return a clock value which is increasing. It will never go backward. But the normal clock value may go backward when the times are adjusted. Next method is ctime. It takes seconds as a epoch second as an argument and convert them into the string, which is same as the ctime method in clang. So we will take a epoch second by using time.time and we'll convert into the ctime. So this is the how date time is represented in string in ctime method. Next method is local time, which converts the epoch time into the timezone struct time object. So these are the parameters of a struct time object, which is a named tuple, and these are the values it can hold. So this is useful when we are transferring date time or exchanging date time over the network. First, the object needs to convert it into the binary, and then the binary object is exchanged between two machines. So for the compatibility reason for the two different systems, this structure or the named tuple is useful. So if we take local time from epoch, as you can see, it will return time.structTime object. Next method is asctime. It will return the formatted string from the struct time object written by the local time. It will return ctime same but from the struct time object. Next is gmtime. It will convert the given time in epoch into the UTC, or formerly known as a GMT time. So as we can see here, if we execute time.local, it will be represented as a given time in as per the local, and if we converted the same object in using GMT time, it is converted into the as per the UTC time. As we can see here, 11:25, and this machine has local IST, which is plus 5:30. So 5:30, 5 hours and 30 minutes are subtracted from this hours and minutes, which will be converted in GMT time. Now next is UTC time to epoch. So same can be reversely converted using calendar module. So calendar module is having timegm method, which will convert the given struct time object into the epoch. Okay. So as we saw earlier, with this method it is returning struct time object, and same struct time object will be given to timegm, which will return epoch time, equivalence of that. Next method is mktime, which converts the struct time into the epoch time. As we can see, it is converting the struct time for representing the local time into the epoch time. Next is a time module attributes. First one is altzone, returns the offset of a second of a local daylight saving time zone with UTC. There is a daylight saving time when, if and only if, this attribute is used. For normal use case, time zone is used to extract the offset of local time zone. So if we execute this, it will return this, which is equivalent to 5.5 hours, which is for offset for the IST. And if your time zone is having DST, you can obtain the same using altzone attribute. Next attribute is daylight. It will return non-zero value if the DST is applicable. And tzname, it will return the time zone name. So it is IST. This brings us to end of the tutorial.